Yeah. Hey guys. Um, so this is going to be volume 2 in an ongoing series for Jamstack. Gavin gave us a good presentation. Not happy I have to follow up that one, but he kind of introduced Jamstack for people that aren't familiar. And I'm going to kind of peel back the first layer and get into some light coding demos. Hopefully that doesn't go terribly, it usually does. So I'm going to be focusing on cloud functions, microservices, and how that all kind of fits together in the Jamstack. And yeah, I'm going to start off with a bit of my background. Okay, so yeah, I started programming in the 90s, kind of, in a time before servers were really a thing you had to worry about that much. So DevOps has always been a bit of a hole in my knowledge. And, when I was in meetings and people started asking questions about DevOps, I would kind of look for somewhere to hide, maybe a pile of coats in the corner, something like that, until it kind of blew over. But things have changed a little bit. So like I mentioned, I started programming in the late 90s, making video games. So, once you made a video game, you would print a CD and FedEx it. So, you're done. You don't have to worry about updating software unless it's sold out and you got to make a version 2. But yeah, so there was not really much server interaction at that point. Multiplayer games had just kind of started, but it was a new thing. And when I made the switch into the web world, I started using Flash. So again, Flash is server agnostic, platform agnostic. So there's not really any DevOps there. So again, I didn't really have to learn anything with DevOps. After that, the transition was to JavaScript. Again, it's front end, not much server side considerations. So I was still able to kind of, avoid DevOps. It was kind of a solution that other people handle, and I was happy to do that. And then kind of in the 2000s, late 2000s, some cool stuff started coming out. Heroku was one of the first platforms as a service. And now there's a whole bunch. Amazon has their own, Google has their own GCP, and then Firebase on top of that, which, puts all the things together for you. Netlify is a big one. So, that's kind of when DevOps was abstracted. And for me, it started becoming fun. And I wouldn't say fun, but, more fun. And it was a lot easier. You weren't in the state where you had to, make a Linux server, install everything you needed on it, manage updates locally. Not only locally, you have to, have all of your servers match exactly the same versions you're using, the same databases, all of that. Otherwise, things would not work. Every time a new team member came on, they had to do the same thing. So, sometimes it takes a week to onboard a new developer, and that was a bit of a pain. And then things kind of switched into containerization, which took away a lot of those issues, made onboarding faster, easier, and configurations were handled for you a lot easier. And then, and then we went to platforms as a service, which is kind of the new standard that's taking over in the web world in a few cases. So, what platform as a service allows you to do is break up your code into microservices. I'm sure you've all heard this word. So people mostly talk about scaling with microservices. It's a lot easier to spin up new versions you know, from an automatic load balancer or things like that. But, you know, honestly, with the types of apps that we're making, scaling isn't really a massive concern. You know, we're not a Google or YouTube or something like that. So the scaling portion is nice, but it's not the one that is you know, the most important part for me. For me, what I like most about microservices is it allows you to organize your services in a similar way that you organize your code. So you can make, you know, little tiny services that have a single responsibility. So they only know how to do one thing and they do that really well. And it's sort of a black box. So you send it something, you send it some input, it does its thing, and it sends some output back. Now that's handy because if you have a whole bunch of microservices that don't know anything about each other, you can swap them out. So you can upgrade all the bits independently. And you can even, you know, write it in a multitude of different languages. So you don't have to make a full team-wide or company-wide decision. We're using .NET or we're using Node. You can make each microservice use a different language, and it can have its own dependencies. So again, for upgrading and swapping out, that's very handy. So some of the hard parts are, you know, things like handling decentralized communication. With the traditional server stack, you know, the client makes a request, a whole bunch of stuff happens, and response is sent back instantly. So that makes, you know, front end communication with the server very straightforward. When you're using microservices, the decoupled nature often doesn't allow that. So another thing is, you know, it's a big paradigm shift. So moving into kind of a whole different world, you kind of feel like you have your hands tied behind your back when you're starting. You know, it's hard to debug, you don't know the tools. And yeah, there's a lot of, you know, things that come around with a big shift like that. So it helps me to think about these sort of things kind of abstracted in a metaphor. So this is one metaphor that I kind of use to compare monolithic applications compared to microservices. You know, at a really high level, how you kind of lay it out and architect it. So I like to think of ant colonies as kind of a decentralized app, and the human body is a monolith. So they both have communication systems. So if you think of an ant colony, each ant is its own individual worker, and it's decentralized. There's no central communication method for every ant. It just knows how to go about its work based on picking up on pheromones. You know, so if there's a whole bunch of food source at one place, ants will leave pheromone trails, so all the other ants will sense that, go over, pick up the food. So the ant colony can scale really easy too. If a bunch of ants die, they make more ants. You know, if there's more food, the more ants will be created. There's different types of classes. You know, the soldiers, workers, farmers, queens. I'm not an ant expert, but you get the idea. So yeah, you can swap out and create new components very easily in that sort of system. Human body is a monolith. So we're basically just, you know, walking colonies of microorganisms. And we have a whole bunch of organs that, you know, keep things going. And those communicate. They have a sort of a data bus of their own, the nervous system, and, you know, hormones and things like that. So it's one big system. If you want to upgrade it, it gets a bit messy. You know, to swap out a lung, it gets a bit messy. It's not as easy. So the point of this isn't to say that, you know, one is better than the other. Each definitely has its own use. So it's another tool in the toolbox. So this is a monolithic, you know, very simple diagram of a traditional web or mobile app with a server-side component here. So typically, if you're on a website, you click a button, you log in, you create a user, you create some kind of entity that you want to store or process. So when a user does that, an HTTP request is sent to your API. So there might be, a whole bunch of systems inside of that server-side application that, process data, hand it off to something else, write a database entry, whatever you need to do, optimize some video. When that's done, the request is sent back to the client, and the client updates. Very simple, but again, there's downsides. So when you switch to something like microservice architecture, everything's split up, and like I said, it's a single responsibility paradigm. So there might be an API, that handles just one specific task, storing some data or modifying data, or whatever, writing to analytics. It might kick off an email notification, SMS notification, things like that. So in order for those components in that system to work properly, you need to write to a central system of some type, some kind of messaging system. So each component can get data, and when it's finished, it writes back. So, there's a few ways to communicate. Databases, event bus is kind of a generic term for these kind of systems. So, one system might be subscribed to a table in a database. So when a new user is added, you might want to, create an entry in a database and do a whole bunch of different things. So once that's done, it'll write back and say, we're done here. And then whoever else is interested in that can pick it up and kind of pick up the ball and take it down the field more, whatever needs to be done. When that's finished, the email system might be looking for those events and say, okay, cool, user's made, send an email to verify, for instance. So this can get messy if you're not thinking about this up front. So like I was saying on the left side there, that's a centralized server with devices that make requests, like I was mentioning. On the right, a lot messier. So it's a decentralized system. So yeah, the communication systems can be a little bit tricky. Another metaphor I like to use when thinking about these distributed or decentralized systems is kind of like a series of mailboxes or a switchboard or something like that. So each system might be kind of like sitting there looking at the window, waiting for their mailbox flag to go up. This is done through a bunch of different ways. You might subscribe to a database when a database is updated or inserted or something like that. That can be your mailbox flag, and it'll be tied to a Cloud Function. So when a certain event happens, Cloud Function gets fired, and the Cloud Function will write back to the event bus, or not, if that's the end of the chain. Yeah, so this is done typically through webhooks. So webhook is just kind of a HTTP method that gets called to kind of notify a system to do whatever needs to be done at that point. So all these terms, serverless, cloud computing, Lambda functions, there's 100 more. These are all kind of in the cloud computing realm, and they all kind of mean the same thing. They just have kind of different flavors or different functions, different functionalities. So it can be a bit confusing, but basically it's a method of abstracting physical servers. So when you hear the term serverless, it can be confusing. Obviously there's a server somewhere, but the idea is that you don't have to make a physical server. You don't have to make an instance. You don't have to make an EC2 instance and SSH in and update all the versions and keep that working with all of your different environments. It abstracts that out for you. So with that comes, obviously some more problems. Dependency management is typically handled through whichever language you're using. Each language has a dependency manager. The big one for JavaScript. These serverless functions are usually based on Node, so it uses npm. Python has its own, .NET. Each language has its own dependency management system. So that's how you handle updates and basically environments. So, if you have the right Node version and you install your Node dependencies, things usually work pretty well. Like any big shift to a new technology or new paradigm, at first you feel kind of helpless. Like, all your typical tools and workflows might go out the window, and you got to relearn how to work with these in the future. So it's kind of akin to building a ship in a bottle. It's not that easy. I'm going to show you guys a few tools that I've found that have made this a lot easier for me, kind of things I wish I knew at the beginning. So cloud functions. What are cloud functions? I'll show you this like a hello world type cloud function. So cloud function can be a lot of things. Cloud function can just be one simple JavaScript function that can do anything you like, or it can be an entire API. So you can use a system like Express and set up HTTP routes, and you can export your entire Express app as a cloud function. So that's really useful. But again, it's how do you debug it? How do you manage updates and versions and things like that? So in this example, this is one use of a cloud function. So if you're using GCP, Google Cloud Compute Platform App Engine, so like I was saying, if you use JavaScript, every cloud function you write is an Express app by default. Now you don't have to use that, but it's really helpful if you have multiple functions or multiple endpoints. So in order to manage that, in this simple example here, so I just created an Express app, and you can use middleware. It's just like any Express app. So I had body parser and cores, and I set a few different routes as examples. So here's some endpoints. Here's an uploads endpoint, organization endpoint. So yeah, this is abstracted. So these are functions that will create endpoints for post, all your typical CRUD endpoints, and then you just export the module as API. So the cloud function will be called API, and it does everything you'd expect from an Express app. So there's a few types of cloud functions. There's one that's HTTP invoked. So it's like any endpoint that you can call from curl or your browser. It's just an HTTP request. You enter a URL and the function gets invoked. So here's an example of all of the languages that Google Cloud Functions support. Yeah, so you can use Node, you can use .NET, Java, Python, Go, and depending on which cloud service you're using, they have different languages, but it's a wide array of languages, so you're not going to be limited usually by that. So like I was saying, if you're on a team, one person might be really good at Go, one person might be good at JavaScript, so you can make a microservice architecture using multiple different languages that communicate through one of those event buses. So these ones are invoked by HTTP. So they're sitting there waiting for someone to hit an HTTP to hit a URL. The other type of functions are called background functions. Those are typically kicked off through an automated process. It might be a cron job, which is just, if it's Monday at 9 a.m., run this function. So cron job allows you to schedule functions based on the time. The other one is pub sub. So the idea there is you can subscribe to, an event bus or a database or things like that. So when some data is changed, modified, inserted, added, anything like that, you can listen to any type of channel that you can imagine, pretty much. So you can subscribe to a database update. So if you want to update some content live on the front end, you can subscribe to a database, and the front end can open a WebSocket or subscribe to that database as well. So you can get a CMS like Contentful or anything like that. So when you do an update to your CMS, the CMS can call a webhook. The webhook can update your database, and the front end can update automatically when that content updates. So that's really handy for making static functions communicate with the backend. So this is just an example, in GCP, how do you manage and deploy cloud functions. I'll show you a few of these in the demo I'm about to do. But GCP, if you guys haven't seen it, it has a dashboard. So I think there's about 400 tabs or 400 options in there. So it's a bit daunting at first. So I'll just show you how to make, bare bones cloud function. You get a whole bunch of things for free. You get SSL, you get hosting. So that's really easy to use. From the cloud dashboard, you can link it to source control. So you can, you can make a really simple and fast CI/CD type pipeline. So every time you commit to a certain branch in Git, it might run through a deployment step. So it makes deployments really easy and fast. No more all-night deployments. So you can just kind of commit your code, run it through some unit tests. If they pass, push it out. And there's a command line tool, which similarly has a lot of options. So you can install a command line tool. So you can, call gcloud init to create a project, and then deploy it all from the command line. This can be scripted, obviously, too. So this is just one example of a typical hello world function in Node. So you can see here that the cloud function exports a function called hello world. All that does, you can see it has the express function signature. It takes a request and a response, sends the response back with hello app novation. So if you go to that endpoint, you get the response hello app novation. This is all well and good, but like I was saying, it's you feel like your hands are tied behind your back at first. It's hard to debug, and there's a lot of uncertainty when you're deploying what's actually being run. How do you follow the code? How do you debug? How do you find, if an error happens, how do you figure out what's going on without pouring through, hundreds of log entries. Um, GCP also has some really good logging features. So there's some machine learning aspects in the log. So if there's something that the machine learning algorithm kind of picks up as not right or an error, it'll flag those for you. So you can enable these. I haven't experimented with those very much, but they seem promising. So this is one of those things that I wish I knew when I first got into this world. There's a few different modules that you can install that really make your life a lot easier. So in this case, I'll be showing you how to use the Google Cloud debugging agent. So you can actually add breakpoints to your code. They're not typical breakpoints because it doesn't stop the execution. So they're called watch points or log points. So when this function gets invoked and you've set up the debugging agent properly with a breakpoint, when this function gets invoked, it'll actually open up your debugger at that line, and you can inspect all of the, all the variables at that point. It's really helpful for debugging. But like I said, it doesn't block the execution. The execution will continue and send the response, but it kind of makes a snapshot at that point that you can inspect. So let me jump in right now. I'm going to switch tabs and just do a little demo here. So like I was saying, this is the, let me just switch accounts. Okay, so I'm going to start by making a new project, and so you can see the project creating. It's actually quite fast. So it usually takes maybe a minute or 10 seconds in this case. So here's the dashboard. It kind of tells you everything that's going on. It tells you all of your API requests, project info, and you can customize this to see what you need. This is just a default look. So like I was saying, there's it's pretty intimidating at first. Yeah, I think it's about 400 tabs or something like that. So narrowing into cloud functions. So you can see that the app was just created. It enabled cloud functions. Okay. So to set up a basic cloud function, I'm going to do this all in the web interface, by the way. This is show you, how simple it can be. This is the bare bones kind of hello world creation. So, like I mentioned, you can have pub sub, or it can be triggered by, a lot of these. So there's a lot of these are beta. Google purchased Firebase a while ago, I think 5 years ago, but there's quite a bit of overlap between GCP and Firebase. A lot of these things are still in beta, like a lot of Google products, they have the beta tag there. They work well. The documentation is a little bit lacking at this point. So I'll leave it at HTTP. You can set up authentication. I'm just going to make this open so anybody can call it. So you can see the HTTPS URL set up. So if I copy this and I go to next, so you'll be able to call this function right away with SSL set up as soon as the function's created. It can take 5 minutes to create the function, so I won't make you guys watch that. I've created another project with the Hello World app set up in it. So like I mentioned, you have to select a runtime. So there's .NET, Go, Java, Node, Python. It supports a lot of Node versions too. So um, so let's deploy this. So like I mentioned, it's not instantaneous. It takes a few minutes. So I won't make you guys watch that. So yeah, I've set up another project in advance so we can kind of avoid any waiting. So in this project, if I go to the Cloud Functions tab, which I'm on, I've already created a function called Hello World. So it shows you the status of it, the region, what type it is, the runtime. So you can see, you know, if something's broken, it'll be very visible. So digging into here, it tells you all of your metrics, how long it takes, how much memory, how often it's used. There's a whole bunch of details here. You can inspect the source code. So like I mentioned, package or dependency management is handled here. So I have the debug agent and I require the debug agent. So I'll be calling this function. So you can see that it's very simple. It's the same function that I just showed you. So in order to call that, under the trigger, in this case it's HTTP, so it just has the trigger URL. So let me, okay. You know, again, I had this created in advance to make this go smoother. There's a few things you need to enable to get this working, but it's very easy. So this is the debugger that I mentioned. So you're able to actually set breakpoints right in your code. So if I take that URL that I copied, this function will get invoked. So you can see hello app innovation was called. Let me see what happened here. You might have to take my word for it. Oh no, there we go. I invoked the function and you can see the breakpoint was hit. So in this example, there won't be much to inspect. It's very simple, not passing in any data. But you can see all the variables. So you're able to view the snapshot of all of the variables data at this point. So it's a very handy debugging tool. And like I said, it doesn't stop execution. So you can see that the response was sent back. I'm still debugging. So you can't step through code, but you can see a snapshot. You can set up multiple breakpoints as well. Okay. So I touched on Firebase. So the cool thing about Firebase is it's a platform as a service in the GCP environment. It also has its own command line tool. It has its own dashboard. So the cool thing with Firebase is it was initially made to be a client-side run platform. So it has really good SDKs, mobile SDKs, JavaScript SDKs. So from the front end, you can create database calls, you can update data, you know, you can do all of your API work from the front end, which is good in some cases. It's great for prototyping, it's great for a lot of things, but it had some problems. But when it merged with the GCP environment, they added cloud functions. So that allows you to make an API and subscribe to a database. It's a document database called Firestore. So when you create a Firebase app, you get free authentication, free hosting, um, real-time database, you know, all these things here. So there's quite a few things you get. Great analytics, performance monitoring, and you know, tons of other things. It's a really good system for prototyping and making production apps too in some cases. So I've got a another demo. I'm going to show you how Firebase can, you know, go through the whole sort of system that I just showed you. So there's going to be an event bus that communicates with webhooks. The front end, there's a front end. This is from an actual demo that we created. We were able to get this prototype in a week or so. So there's a JavaScript front end that's been created already. And I'm going to step through a few of those features about how the front end is updated automatically from Contentful. So Contentful is the CMS we used. So, you know, quite often in a statically hosted site, it's sometimes hard to be dynamic. But using these tools, we were able to make an application that updates automatically when you make changes to the CMS, which is pretty neat. So let me show you. So this is the app. It's a simple dashboard. Basically, this is, you know, you can display this on your meeting room TVs or your you know, any displays you have in an office, something like that. So, like I mentioned, we use Contentful. Contentful is a headless CMS, if you're not familiar with it. It's used quite often at Appnovation in the last couple of years. So let me show you what happens if get the screen templates. Okay, so you can see there's a whole bunch of different widgets here. So there's a gallery with images. There's a list of events. You know, any type of widgets you want, you can display here. But what I was mentioning is, if I update data in Contentful, Contentful then goes and calls a webhook. So you can see this webhook is a post to this URL. Now that URL is, just like I mentioned, it's a cloud function, just like the one I created before. You can inspect the source. So if I call a function inside of content, all it's going to do is write to the assets database, the Contentful database. So it'll take everything that's updated in Contentful, write it to the database. The front end is subscribed to this database. So when this changes, the front end changes automatically through a WebSocket. WebSocket is a live communication channel through the front end to the server. So most of the time a request is terminated after you get the response back. A WebSocket's left open. So you can communicate two ways. So the server can push data to the front end. So, you know, in this case, when the data in Contentful is updated, it'll call this cloud function. So let me find the entry for this. So if I want to do something simple, let's say I want to reorder those events. So you can see there's new team members, family bowling. let's say I want to promote this event. So I just reorder these inside Contentful, publish those changes. When I hit publish, it'll call WebSocket. The cloud function will pick that up, update the database. And yeah, there you go. So you can see that's been updated with no refreshing, anything like that. There's also another widget. So it's an announcement. So if you want to, push an announcement to every screen in your system, you can just do it with your CMS. If you do it properly, it'll work. Yeah. So everything seemed to work pretty well. So that's the end of it. Let me know if you guys have any questions. Give you guys a couple minutes. No questions? Okay. Thanks, everyone.
Thank you, Joel. Thanks, everyone.
Thank you.
Thank you. Thank you.
Thank you.